Hello students, this is Saranya, Assistant Professor, Department of Mathematics. Before going to this chapter, all of you welcome to our online class. Same chapter, Unit 2 Matrix. A problem topic is orthogonal reduction of a symmetric matrix to the diagonal form. This topic we have to see the previous video. We have to discuss the definitions orthogonal matrix and then how to solve the by using the definition how to solve the orthogonal matrix. This right now we have to solve the same chapter is orthogonal reduction of the symmetric matrix to the diagonal form. We have to solve the another problem based on using the eigenvectors of a real symmetric matrix of the orthogonal pairs. Before going to the problem, we have to know about the steps. Steps is followed by orthogonals in pair. First three steps already are all well known. First step 1 is to find the characteristic equation. Step 2 is to find the eigenvalues. Step 3 is to find the eigenvectors. The final one more step is to find the conclusion part is orthogonal. Check whether the orthogonal pair x1 x1 to x2 transpose equal x2 into x3 transpose equal x3 into x1 transpose are equal. Both the three transpose are equal. You have to final conclusion part. The conclusion part with the help of what is x1 x2 now, with the help of this eigenvectors value x1 x2 x3 value, you can use this orthogonal pairs. Check whether it is an orthogonal pair or not. Now we have to going to see the problem. To verify the eigenvectors of a real symmetric matrix A, this is the given matrix is a 3 by 3 matrix on 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3 or a orthogonal in pairs. You have to check whether it is an orthogonal pair using the eigenvectors and then verify that orthogonal pairs. Now next going to solve this solution. You have to going to solve this problem. First you have to write the solution. What is the given here? Given matrix, you have to write it here as it is. You have to write it A. First step, you have to solve the solution. Step 1. Step 1 is what you have to find the steps they are given in a step 1. What is given in here? Step 1 to find the characteristic equation. How to find the characteristic equation? Already you all know see about the characteristic equation in eigenvalues eigenvectors problem. You have to know about the equation. The given matrix is 3 by 3 matrix. Now you can using this equation. The equations is cubic polynomial lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. With the help of this equation, you can solve that equation. With the solve that equation of S1, S2, S3. How to solve the S1, S2, S3 now? With the help of this given matrix, you can solve the S1, S2, S3. Before going to find the S1, first you have to know about what is characteristic equation of A. Lambda cube S1 lambda square plus S2 lambda minus S3 equal to 0. First you have to find S1. How to find the S1? S1 is the sum of the main diagonal element. With the help of that given matrix, you can solve the sum of the main diagonal elements. So what is the diagonal element here? A11 plus A22 plus A33. You can add. What is the diagonal element? A11 is 3. Write it over here. A22 is what? 5. You have to write it here, and A33 have to substitute the A33 value is 3. These only the diagonal element 3 5 minus 3 5 3. This is a diagonal element. This upper triangle matrix is a lower triangular matrix. Left over this is a diagonal element 3 plus 5 plus 3. This is your diagonal element. S1 is sum of the diagonal elements equal to, you will get answer 11. So we have to put it in box. S1 equal to 11. Next to find the S2. S2 is with the help of the given matrix, you can solve this sum of the minor or a principal diagonal element. Sum of the minor or a principal diagonal element. That is nothing but this is nothing but you can take the cofactor of the given matrix. You can take the cofactors of the given matrix. You can take the codeterminant of the given matrix. How can solve now? First you have to write the converted into 2 by 2 determinant matrix. Given matrix is 3 by 3, you have to convert the cofactor of the matrix determinant. You can take the determinant minor of the matrix. How to take the minor of the matrix now? S2 equal to sum of the minor or principal diagonal, which is equal to you can just left over, just see your given matrix A. Here you have to determinant matrix, the first determinant matrix A11, A12, A21, A22. How can write this now? Last column and then last row you have to lift over there. Rest of the matrix you can take it, put as a determinant, that is like write it as A11, A12, A21, A22 plus again another one of the matrix, because 3 by 3 matrix, no, so you will get the 3 determinant matrix, 3 principal diagonals. Another one is again you have to lift over the given matrix, first row first column lift over, and then take it rest of the matrix you can take it as determinant A22, A23, A32, A33 plus again another final one is a second row second column left over, rest of the element you can take, put the determinant A11, A13, A31, A33. Now substitute all the values over here. A11 is what? 3, put it in 3. A12 is what? -1, put it over here. And then A21 is what? -1. A22 is 5, and then plus another determinant matrix is what? A22 is 5, another A23 is -1, right, put it over here. Now substitute A32 value is -1, substitute A33 value is 3, write it here, plus A11 is 3, write it here, A13 is 1, A31 is 1, A33 is 3, write it over here. Now you can take the determinant, you can solve this 2 by 2 determinant matrix, solve and then add. 3 5s are 15, write it here, minus into minus plus, already you have determinant, you have one minus here, so 15 minus 1, again second determinant value 3 5 3s are 15, minus into minus plus, okay, you have to again already have a determinant, you have one minus over here, so 15 minus 1, 3 3s are 9, and then 1 into 1 minus 1, already determinant you have a 1 minus, so you have to put a middle minus and then 1, and how you have to simplify. 14, 15 minus 1 you will get 14, again 15 minus 1 you will get 14, 9 minus 1 8, you have to add all this, only 14 plus 8 you will get 36. Therefore S2 value equal to 36. Another one is what you have to solve? S3. S3 means you can take the determinant of value A. You can take the determinant of value A. Given value you have to take the determinant. Given matrix you have to write it a determinant matrix, 3 by 3 determinant matrix. Already you are all well known how to solve the 3 by 3 determinant matrix. You have to study it in a lower classes. So first you have to write it over 3 here, and then you have to convert it into the first row first column left over here, and rest of matrix you have to take the 2 by 2, convert into 2 by 2 matrix. You can take the determinant 3 5s are 15, minus 1 into minus 1 is plus 1, more determinant you have a minus 1 here, put it in 1 minus, and then minus, and then next you have to find the middle value, choose. Already in formula you have a 1 minus, put it over here. You can take the minus 1, the first row second column left over, minus 1 into 3 you have to put minus 3, minus 1 into plus 1 you have to here minus 1, already in this determinant you have 1 minus, so you have to get the plus 1, plus 1 you have to first row last column left over, and then minus 1 into minus 1 is plus 1, and 5 into 1 is minus 1. So you can just, you have to simplify like this, 3 into 14 you will get what, and then minus 1 into minus 3 plus 1 you have to simplify like that, you will get this. You will get in 3 into 14, you will get in 42, and then minus 3 plus 1 is a minus 2, minus 1 into minus 2 plus 2, already 1 minus, so you have to get the minus 2, plus 1 minus 5, you will get a minus 4, plus into plus 1 into minus 4, minus 4, so you will get a S3 value is 36. Then you have to found no s1 s2 s3 no. You have to substituting the s1 s2 s3 value in your characteristic equation A. You have to find, you have to substituting the corresponding s1 value, s2 value, s3 value. You have to going to substitute here. The characteristic equation of A is equal to lambda cube minus s1 is what, 11, put it over here. S2 is what, 36, put it over here. You will get like that. And then S3 is what, again 36, put it over here. Then you will get the 36, which is equal to 0. Then you have to find the roots of first you have to find the s1 s2 s3 value. You have to substituting the characteristic equation lambda cube minus s1 lambda square plus s2 lambda minus s3. You have to substituting your s1 value minus s1 value 11, s2 value 36, s3 value 36, substituting here. After that you have to check whether the roots. Why? Because we have to root. I want to find the eigen values. So for that, in this equation we have to find it. This is a cubic polynomial here. So first we have to check whether the roots. You can check in lower classes. You have to find the roots. Know how to check the whether roots. First you have to lambda equal to plus or minus 1, plus or minus 2. You have to check each every one. I have to get the answer. Lambda equal to 2 now, I will get the equation will be 0. And now we have to substituting here with lambda equal to 2, here 2 cube minus 1 11 minus 11 into lambda value is 2 square plus 36 into lambda is 2 minus 36. Now we have to substitute and simplify. 2 cube you have to know that 8, and then minus 44. 2 square is 4, 4 into 11 you will get in a 44 plus 36 into 2, then minus 36 you will get answer is 2. So lambda equal to 2 is a root. Why? Because you will get in a value which is equal, you have to apply the 2 in lambda na, that value equal to you will get a 0 na, that is a one of the root. The cubic polynomial na, you have to get the 3 eigen values. So it is a squaring term now, you will get a 2 eigen values. If it is cubic, the given problem is a 3 by 3 matrix cubic now, lambda cube equal cubic value now, you have to get the 3 value. I get the 1 roots. Now I want to find the another 1 roots. How to solve another 2 roots now. By using this equation we have to using the synthetic division. By using the synthetic division, how to find the synthetic division, already you all know about the synthetic division. In lower class you have to study. So again no problem, again I have to repeat it. This is your leading coefficient. What is your leading coefficient in your lambda cube equal to 1? Lambda cube is a leading coefficient is 1, and lambda square leading coefficient is minus 11, and lambda leading coefficient is 36, and rest of constant part minus 36. You get the one root, no, you have to put it here, and then first step you have to 1 na, you have to put the 0 here. You can add these two, 1 plus 0 again 1, again you have to cross the multiple. 2 ones are 2, put it over 2, 11 minus 11 in plus 2 you will get a minus 9, again you have to cross multiple. This is a reminder, quotient will you have to 0, you have to get the 0. Minus 11 plus 2 you will get a minus 9, again you have to cross multiply. Minus 2 in plus 2 into minus 9 equal to minus 18. Now you can add plus 36 minus 18, you will get 18. 2 18s are 36. This is a negative 36. This one is a positive. You will get a reminder, you will get in a 0. This 2 where it come now, already you have to find the root value, no 2. That root value you have to put it over here, and then you can take the division. Each and every term, just you have to put first element, corresponding the first element you have to put the 0, and add these 2 element, you will get 1. Again to cross multiple, 2 ones are 2, again you have to add these 2. Minus 11 plus 2, you can subtract that, minus 9, and then 2 into minus 9 you will get minus 18. Again add this plus 36 minus 18, this is you can subtract this, plus 8. 18 to 8 so 36. This one is a negative, this one is a positive, equal to 0. Your remainder will be 0. What is the question? Then you have to get the root. First given characteristic equation cubic now, you have to convert it into the algebraic equation. Then only you have to get the another two roots. The first root is what? You have to write it over here. To find the factorization, you have to write the first root is what? Lambda equal to 2. Write it here. And then second algebraic term, with the help of how to get the second algebraic term of this equation, this quadratic equation, how to get now? With the help of this, you have to solving the characteristic equation by using the synthetic division. You will get this finally you have to get this value, no? What value? Finally you get the value, no? 1 minus 9 18. So you have to write this 1 is lambda square. You have to reduce the term, the cubic term, you have to convert it into square term. So lambda square minus 9 lambda plus 18 equal to 0. This equation is algebraic quadratic equation, so you have to use factories. Again this equation easily you have to factor a cubic. Now cubic means you can directly have to first you have to check whether the root, after that root value you have to find the synthetic division. After that why? Because using the synthetic division now we have to reduce that equation, in a quadratic form, in algebraic form. Then that equation you can using the very easily to use the sum and product rule over here. How can you use the sum and product rule here? Already you all know about first root. I want to find the root value, the factorize that equation, this equation only, lambda square minus n lambda plus 18 equal to 0. Then you can using the sum and product rule. How to make the sum and product rule? Now you have to write it here 18, you have to add, you will get that value. Add, you have to get the minus 9, and then product you will get 18. So I have to write it here 3 and minus 3 minus 6, minus 3 minus 6 I will get a minus 9, minus 3 into minus 6 I will get 18. So I have to get the lambda equal to 2, write it here. So we have to write the equation form lambda minus 2. Here how can I split like this? This algebraic term lambda minus 3 into lambda minus 6, which is equal to 0. Then finally have to find the root. Lambda minus 2 equal to 0. Now you can just find the lambda value. How to find lambda minus 2 equal to 0? Now lambda equal to 2. It is a positive, it goes on other side. Now it goes on other side. Now you will get a positive 2. Lambda minus 3 equal to 0. Now it goes on another side. Now lambda equal to 3. Similar to this, lambda minus 6 equal to 0. Now lambda equal to 6. So you have to get the 3 eigenvalues. Why I have to get the 3 eigenvalues? A given characteristic equation is a cubic, so I have to get the 3 eigenvalues. And then step 2. What is the step 2? You have to find the characteristic eigenvalue, no? So that is why you have to take it in, right? So to find the eigenvalues, lambda equal to 2, 3, 6. This is your 3 eigenvalues. This is your step 2. Next we can find the eigenvectors. How to find the eigenvectors? A minus lambda I of x equal to 0. That is a eigen characteristic equation. With the help of the characteristic equation, characteristic vectors you have to find. That is called it as eigenvectors. Solve the A minus lambda I of x equal to 0. How can you solve this now? Given matrix A, already you all know about A, and then minus lambda I x equal to 0. 3 minus lambda I, given matrix. First you have to write the given matrix. What is our given matrix? A, you have to first write the given matrix. 3 minus 1 1, A minus 1 5 minus 1 1 minus 1 3, 1 minus 1 3, write it here, and subtract that minus lambda into I is what? Identity matrix. First you have to write A matrix. First you have to write the A matrix and minus into identity matrix 1 0 0 0 1 0 0 0 1, and capital X is what? x1 x2 x3. Why? Because this is a 3 by 3 matrix, so equation you have to get a 3 equation over here, x1 x2 x3 0 0 0. And then now we have to subtract that identity matrix. 3 minus lambda, diagonals always have to subtract with the minus lambda. 3 minus lambda, 5 minus lambda, 3 minus lambda, and upper and lower triangle you have to write it as it is. What is the x here? Capital X here, x1 x2 x3 and 0 0 0. Now you have to use how can you solve this find this matrix now by using the eigenvalues. By using the eigenvalues, you get the eigenvalues or three eigenvalues. No, we have to take each and every one values. You have to substituting that equation. First, you have to consider the lambda 2. First, you have to consider the lambda 2 in equation 1. Which one is the equation 1? This is your equation 1. Now you have to substituting here lambda equal to 2 in this, put it in equation 1. 3 minus 2 minus 1 1 minus 1 5 minus 2 minus 1 1 minus 1 3 minus 2. All the lambda you have to put it into, that is call it as a first lambda equal to 2, that is a case 1. With the help of this equation you can use this, and then after that you have to solve like this, and capital X value here x1 x2 x3 and 0 0 0. Now you have to simplify this matrix. You will get 3 minus 2 is 1, 5 minus 2 is 3 and 3 minus 2 is 1, and the upper and lower triangle you have to write it as it is, and then x1 x2 x3 then 0. Now this matrix is multiple with this equation. Already you have to know about the matrix multiplication. First row and then first column you have to multiple. You will get one equation. 1 into x1 x1 minus 1 into x2 minus x2 plus 1 into x3 is x3, which is equal to 0. You can take it, write it as this is a equation number 1. Another one, second row and then first column you have to multiple. Minus 1 into x1 minus x1 3 plus 3 into x2 is 3x2 minus 1 into x3 is minus x3, which is equal to 0. Finally you can write, take the matrix multiplication on last row and then first column you have to multiple. You will get the last equation. 1 into x1 is x1 minus 1 into x2 is minus x2 plus 1 into x3 is minus x3, which is equal to 0. You will get the 3 equation. No, then 3 equation you have to choose any 2 equation. You have to choose any 2 equation. By using the cross multiplication equation you have to find the first eigenvectors capital X1. How to solve? You have to see, this is a remarks. You can use with the help of this remarks we can solve the capital eigenvalue x1 eigenvectors. Capital X1 eigenvector, you have to solve the eigenvectors capital X1. Now just see, just you have to consider by using the how to solve. I want need the x1 x2 small x1 x2 x3 value. So how to solve? We can solving this by using the solving the elimination method. It very big process. So for that it is a short trick by using first 2 equation. Now you have to consider the first 2 equation by using the cross multiplication rule method. What is the formula? Now this is your equation. This is studied about, you have to study in this format in lower classes. Just we have to apply here. a1 x1 plus a2 x2 plus a3 x3 equal to 0. b1 x1 plus b2 x2 plus b3 x3. We have to choose any 2 equation, 1 2 or 2 3 equation you have to choose. Before solving you have to use this formula. Now I want to find the cross multiplication. How can you find the cross multiplication? Now first you have to split first equation. You have to you take that a1 x1 plus a2 x2 plus a3 x3 equal to 0. b1 x1 plus b2 x2 plus b3 x3 equal to 0. Just you have to cross multiply that matrix. First you can take the last 2 values of this equation. Last 2 values is what? a2 a3 b1 b2 b3, sorry, a2 a3, write it here, a2 a3 b2 b3, and then last you have to write it here, first two equation. What is the first 2 equation? a1 a2 b1 b2. You have to just keep it in mind. First you have to write it in this equation. The last 2 leading coefficient you have to write it as it is, a2 a3. x2 leading coefficient is what? a2. x3 leading coefficient is a3. x2 leading coefficient is b2. x3 leading coefficient is b3. Another one, I want to find the x2 value. No, so you can just left over the x2 value. You can take it and write a leading coefficient x1 and x3 is the last you have to write. I want need the x1 value now. First you have to write the x2 value. x2 and x3 leading coefficient first you have to write, middle you have to write x1. After that I won't need the x2 value, no, so I have just left over the x2 value, then you can write it as a1 a2 leading coefficient, b1 b2 leading coefficient of x1 x2. Then middle you have to write x1, this middle you have to write x2, this middle you have to write x3. Now you can I won't need to find the value on x1 here now, so how can you write this? You have to multiple and then subtract, just determinant matrix only, you have to convert into determinant matrix like that, a2 into b3 minus a3 into b3, that is your x1 value. x2 how to find na, a3 into b1 minus a1 into b3, write it over here. x3 I won't find the x3, small x3 value now, a1 b2 and then a2 b1. Already you all know about how to solve this, just by using this cross multiplication rule method and substituting this equation. Now you have to choose your given equation. What is your given equation? 1 and 2. Solving by first two equation using the cross rule method. What is how to use a cross rule method? x1, just you have to take the value here. What is the x1 x2 x3 now? You have to put it over here. Now you have to substituting that value, corresponding value, you will get x1 equal x1 by 1 minus 3 minus x2 by minus 1 plus 1, which is equal to x3 by 3 minus 1. x1 you have to simplify that value, x2 you will get 0, x3 you will get 2. Therefore the capital eigenvectors, capital x1 equal to minus 2 0 2, which is equal to 1 0 minus 1. This is your first eigenvectors, capital x1 equal to 1 0 minus 1. Another eigenvalue, you can choose another eigenvalue, you can substituting the equation in 1. What is another eigenvalue? You can take it as case 3. Why? Because case 1, case 2, case 3 now you have to substituting the all eigenvalue, then only you have to get the all 3 eigenvectors. So for that, with the help of the eigenvalue, you can using the all lambda values, then you have to find the eigenvectors, lambda equal to 3. Now substituting over the in the first equation, you will get a one matrix. Again you have to get the equation, one of the equation like this, matrix multiplication, then you have to get the equation. Again you have to using the solving the first two equation by using the cross multiplication method. With the help of this rule, you will get this value. Finally you have to get a capital x2 equal to 1 1 1, another one lambda equal to 6, that is a third eigenvalue. Final one you can put it, that one is a case 3, lambda equal to 6. You have to substituting in the equation 1. Which one is your equation? This is your equation 1, lambda equal to 6. You have to substitute, you will get this matrix. Then you will to get the another one of the matrix you have to get. After you have to using the matrix multiplication, you have to get the another equation. Again you have to solving the first two equation, you can take it as to solving the by applying the cross multiplication rule method. You have to get the final x3 eigenvectors. Then finally what is the step 4? You have to take it and then write in all eigenvectors. x1 is what? By using the first eigenvalue, you have to get the one eigenvectors, capital x1 1 0 minus 1. Another one is x2 is what? By using the lambda value 3, you will get the eigenvectors x2 1 1 1. You have to write it over here. And then x3 is using the another third eigen lambda 3 equal to 6. You have to substitute that value in equation eigenvectors, and you have to get the x3 equal to 1 minus 2 1. Substitute here. Finally you have to get the verification part. How to find the verification part now? Already you have to see the step, no, final step 1. To find the orthogonality condition. How can you find the orthogonal condition? See like that, this is your formula, no, orthogonal pairs checking condition. This is your condition, x1 x2 transpose, x2 x3 is transpose. You have to apply over here. x1 x2 transpose equal to 0, x2 x3 transpose equal to 0, x3 x1 transpose, you will get 0. Now you can choose x1, write it here as it is. x2, it is a column wise, you can take the transpose now, it will come a row wise. So you have to matrix multiplication. First column first row you have to multiple first column and then first row. 1 into 1 is 1. 1 into 0 you will get 0. 1 into minus 1 equal to minus 1. So what is the answer? 1 plus 0 minus 1, you will get 0. So first condition is satisfied. And then move on the second condition. With the help of the second eigenvectors x2 and then transpose of a third eigenvector x3, we have to take the multiple. X2 you have to write it as 3, x3 here a column wise you have to you can take the transport. Now it will become row matrix. One column and then one row you have to add. Again you have to get the 0. And then x3 x1 transpose. x3 is what? 1 minus 2 1. x1 you have to take the transpose. 1 0 minus 1, okay, you have to get the 0. So for that all the three conditions, all the orthogonality of the three conditions are equal to 0. All are equal. Now the given eigenvectors pairwise orthogonal, hence the solution.